How do we graph a function like this without using any graphing calculator technology? I'm going to show you first by hand how we do this from scratch, and then we'll go into Desmos and see if we match up with our sketch. So we have a few steps, three in particular. I wrote them here. We're going to start by finding the zeros or x-intercepts and plot them on a graph, make a sign chart just for f of x, and then do our best to sketch using the multiplicities around those zeros. Let's put those steps off to the side and work on our working space. Okay, so step one, I want to figure out what are the zeros of this function. That's going to be anything that makes each of these individual binomials equal to 0. So that would be x equals 3 is one of the zeros. Solving for 3x minus 1 equals 0. Right? We should get positive 1/3. So x also equals 1/3. And the final 0, or solution here, we have x equal to positive 1. I'm going to put those in order. So starting from the smallest, we have 1/3, positive 1, and then 3. Great, step 1 done. Next. Oh, actually, I didn't finish step 1. Let's plot them as well. So I'm going to make some space for a graph on the side. This is going to be our best approximation of a sketch. So I have 1, 2, 3. Let's plot 1/3 here. All the zeros are just going to be a x-intercept dot on the x-axis, and then we have positive 1 and positive 3. Okay, now step 1 is done. Step 2, what do we do next? Let's make a sign chart for f of x. Great. Let me erase all this mess I made. Okay, so the sign chart, you could do it vertically or horizontally, either way. But you plot all of them in order here. So we have 1/3. These are the x values. Positive 1, positive 3. And what I like to do here is how you would look at it if you wanted to do it vertically instead. You plug in values essentially that are within each of these 4 intervals to determine, are we going to have positive y values as a result of plugging those values in, or are we going to end up with negative y values? Why is that important? If we get positive values, for example, between 1/3 and 1, that would tell me that in that region here between 1/3 and 1, we would have a graph that would strictly be above the x-axis like that. So that's going to be the essence of what we're finding here. I actually like these dotted lines. Let me create these partitions for us here. But that I don't know if it was positive or not. So let's plug in any values less than 1/3. I like to use as easy numbers as possible. So let's put a 0. Between 1/3 and 1, 1/3 is the same as 0.33. So maybe we could plug in a 0.5. Between 1 and 3, I know 2 is in between there, and something above 3 is 4. Simple. Okay, so what I like to do, plug these numbers into f of x. All right, you'll start with 0, for example, our first x value to plug in. Oh, and this is to the 3rd power here, and then 0 minus 1 is squared. Zoom in here. Okay, so you notice 0 minus 3 is going to become a negative value. So what I like to do, instead of writing the actual value, the sign chart, we just care about the sign, not the actual value. So for this region here, I would just put a negative on top. For this expression here, 3 times 0 minus 1, that's also going to be negative. The last one's pretty nice because it'll always be positive. Even though 0 minus 1 is negative, that power of 2 creates a positive value every time. So I essentially have a negative times a negative times a positive, and that becomes positive at the end. So that's how I make my sign charts. Instead of all of this plugging in values, I like to think really in this simplified and reduced way. So that's how I'll create my sign charts here. Let me copy down the function here again. We had x minus 3 to the third power, 3x minus 1, and then x minus 1 squared. Okay, so again, when we put in 0 in for all of this, we end up with 0 minus 3 to the third becomes negative. 3x minus 1 with a 0 in it also becomes negative. 0 minus 1 squared is negative, but squared becomes positive. So the last ultimate sign is a positive. Try that for 0.5. 0.5 minus 3 to the third, definitely negative. 0.5 times 3 minus 1, what is that? 1.5 minus 1, that's a positive. And then we have, the last one will always be positive because we're squaring. So this ultimately is negative. Now plug in 2. Again, I'm plugging into this function here. So 2 minus 3, negative 1, that's negative. 3 times 2 minus 1, that's positive. And then positive again. Oh, so we got two negatives consecutively. And then finally, 4 minus 3, when I plug in, becomes a positive value cubed. 3 times 4. Oh, all of them are positive. Okay, great. So those are our 4 signs. Right, so on our sign chart, that's going to look like positive, negative, negative, positive. Great. Step 2, complete. Okay, so now we can make a sketch using the multiplicities and these signs from our sign chart. So I'm going to go back here to our graph. And take a look at, I'll use some colors here, our positive values. So anything less than 1/3, we're going to be in this region up here. Anything above or greater than 3, we're going to have also values above the x-axis here. But then as soon as we get to the values, the regions between, right? 1/3 and all the way up to 3, those are going to be curves that will fall below the x-axis. So getting closer to what this graph will look like. Now let's take into account those multiplicities. So what does that mean? Multiplicities have to do with what are the order of those solutions. So the multiplicity of x equals 1/3 starting from the smallest value is equal to just 1, right? Because it didn't have any power there, so it's implied that there's just a power of 1. The next one in order was positive 1. That had a power of 2, so that means its multiplicity was equal to 2. And the last one had multiplicity of 3. Again, why? Because that was the power associated with that specific solution. Great. How is this helpful? Well, multiplicity tells us what our curves will look like. So we know that with anything that has multiplicity of 1 will have a linear curve to it. Multiplicity 2 tells us we'll have a parabolic curve. And then finally, multiplicity of 3, that's going to be cubic. It's going to create a shape that looks sort of like this, or maybe like this. Parabolic looks like positive or negative. Parabolas, linear lines, right? Okay, so then that means that the region here, when we are crossing the 1/3 solution, we need to have linear graphs like this. So it's either going to go in this direction or it might go in this direction. But you see how those signs that green and red highlighting tells us that definitely it should go in this direction. First, we're in a positive um, or we're in a positive region, and then we're going down to a negative region. Also, I should make a correction here. Just realized that it could make a line, but it could also just be, it could also have a curve to it. What happens with multiplicity of 1 it means that we're crossing a solution without bouncing off or creating something that crosses that solution in a cubic way either. It just crosses one time. Um, and if you zoom in, it's more, it reflects more, resembles more of a linear um, curve rather than parabolic or cubic. So then we can have a graph that's doing something like this, for example, or like that. But we know it just crosses once. Um, but let's move on to the next solution here of +1. So that one has what kind of shape? It says parabolic. So that we know for sure will either have a shape like this, or maybe it'll have a shape like this, seeing that our sign chart gave us all negative values from 1 to +3, right? We have only red shaded region. I have a feeling it's going to do something like that shape. So we have to keep all this in mind, sort of keep track. Finally, we get to our last solution, 3, that has multiplicity of 3. So it's going to have a cubic shape to that curve. So either it's going to do something like this or something like this. Oh, I already did that. It could do this or it could do that. But the reason why this probably wouldn't work is because that's going from positive to negative, whereas our graph went from negative to positive, as you can see from the shadings that I included to help guide us. So this is great. So we know we have something going like this, like that, some kind of shape going down like that. So putting that together so that it's a bit more smooth than what I created, this fragmented shape here, I'm going to do my best to do our final sketch. Okay, so we're going down, passing this, but then we have to, oh, it straightened the line for me. But then after we pass that, we know we have to bounce off of that solution to create a parabola. And then somehow I have to get this to look cubic. Ah, okay. Some almost wonky W shape, right? Okay, so there's our sketch. Let's see how close we got to the right answer. I'm going to look into Desmos. We're going to try to make a graph. Let me take a screenshot so we can compare later. Okay, so the function was x minus 3 to the power of 3, 3x minus 1, and finally x minus 1 to the power of 2. Let's see what we got. Okay, not too bad. So you could see that when we pass the 1/3 mark, we have just a single crossing of that 0, and then we have that upside down parabola, matches with ours. And then, yeah, it curves back up so that we can essentially get that cubic shape that we wanted to go from negative to positive. So everything matches with our sign chart and with the multiplicities that we indicated from our zeros. Okay, so that's how you do a sketch with and without technology.